Welcome, MA 103 students. This is a continuation of the cookie jar problem and is linked to a past lesson objective from the lesson entitled Mathematical Modeling 3, Interpret. Specifically, it is the lesson objective, discuss how sensitive a solution is to the assumptions. You can see our focus truly is on the third leg of the USMA mathematical modeling process, as well as the iterative process indicated by the 3 arrows inside of the triangle. In our first video AIs concerning the cookie jar problem, we were able to transform this problem into a mathematical model. That mathematical model was then manually iterated, as well as iterated through the help with Microsoft Excel, to solve and determine P sub 250 and P sub 500. Here, we want to focus on answering the questions. Does the solution answer the question? How sensitive the solution is to the assumptions, and then be able to translate the results into non-mathematical terms. I'm going to spend some time talking about sensitivity analysis as part of this interpret step in the iterative process. We define sensitivity analysis in modeling in a real and complex world. And the intent is that we want to determine if we changed our assumptions, would that change our solution? And that's the process that we're going to go through here in this video AI. So let's examine those assumptions. So initially we made the assumption that we were going to make consistent deposits in our cookie jar on workdays and every workday. Additionally, we made the assumption that we worked 5 days a week for 50 weeks out of the year, allowing for 2 weeks of vacation. 5 times 50 equals 250, hence 250 days, work days in 1 year. Using this assumption, we determined P sub 250 and P sub 500. And our mathematical solution indicated after 250 work days, this would equate to 202.5, and after 500 work days, this would equate to 390. First, in the interpret step, let's see what this means in terms of how much money will be in the jar after 1 year and after 2 years. The answer to P sub 250 does mean there's $202.50 in the cookie jar after 1 year of this consistent behavior. And this is for an increase of $187.50 in the cookie jar. We can make the same conclusions for 2 years. This indicates that there's $390 in the cookie jar after 2 years, with the increase being $375 in the cookie jar. But what if we change those assumptions, specifically the last assumption? And instead, we assumed that we got 4 weeks of vacation a year and only worked for 48 weeks. This would change our mathematical solution. We would then seek to determine P sub 240 for 1 year and P sub 480 for 2 years. And through Microsoft Excel, we would be able to iterate, just as we did before, to find these values. We can do the same thing if we only assumed a 5-day work week, but did not make an assumption for vacation. This would indicate that we would work 52 weeks out of the year. And we would seek to solve P sub 260 as well as P sub 520. Another possibility would be if we made no assumptions at all concerning the amount of days worked in a year. And if we do that, we would use 365 days for 1 year and 730 days for 2 years. This table summarizes our findings based on changing our assumptions. We have our initial assumptions, change 1, change 2, and change 3, which was as though we made no assumption at all. I asked you the question, do our assumptions truly affect the solution? I would say just by visual inspection of this table, it's obvious that they do. After 2 years, the possibilities for the value of the money in our cookie jar range from $375 to $562.50, which is 1.5 times as much. That's a considerable difference. In the textbook, we offer additional insight into further steps for a complete sensitivity analysis. Here, the intent was to show you that your reasonable and necessary assumptions really do affect the solution. Happy modeling, and thanks for watching.